This is example 2 of the compounded interest and continuously compounded interest lab. For example 2, we have this problem. We have $3,725 is deposited into an account that is compounded continuously. Find the annual interest rate if the account is worth $5,225 after 7 years. So we have this phrase, compounded continuously. So we have the formula for continuously compounded interest, which is A equals PE to the RT, where A is the amount accumulated after T years, P is the principal or the starting amount, and R is the interest rate in decimal form, and T is the time in years. So we're going to find which of these we have and which we don't in our problem. So we have $3,725 is deposited into an account. So if we look back at our formula, that is going to be our principal or our starting amount. So we have P is equal 3,725. Then it says find the annual interest rate. So we know that we're looking for our R. If the account is worth 5,225 after 7 years. So 7 years is our time, and 5,225 is our A, is the amount accumulated after T years. So A is 5,225 and T is 7, and we're looking for our R. So that's what we're looking for. So we're going to solve for this. So we have A is equal to PE to the RT, and we're looking for our R. So we're going to substitute each of these, what we have, into our formula. And we'll do that on another page. So we have A equals PE to the RT. Our A is 5,225. Our P is 3,725. We don't know what our R is, so we leave it as R. And our T is 7, so after 7 years. So we're going to solve for R in this equation. Oh, this is E times E to the R7, excuse me. So we're going to divide each side by 325 to get R alone. So we have 5,225 divided by 3,725 is equal to E to the R times 7. And then we need to bring down this exponent from the E. And the way we do that, since this is E, we're going to take the natural log of both sides, because the natural log has a base of E, and it'll essentially cancel out this E and bring down this exponent. So taking the natural log of both sides, we get the natural log of 5,225 divided by 3,725 is equal to the natural log of E to the R7. And in any kind of logarithm, there's another rule that we can bring this down to the front, and then this will just essentially become into 1. So we have, in essence, natural log of 5,225 over 3,725 is equal to R times 7. And then we're going to divide by 7. So this is going to be divided by 7. So we get R is equal to ln of 5,225 divided by 3,725 over 7. And putting that into a calculator, we get that R is about 0.048341. But generally speaking, when we're writing a rate, we want to write it in percentage format. So this is going to be in percentage format. We have to move the decimal over twice. So we have R is equal to 4.8%. And so we have R is equal to 4.8%. And that is our annual interest rate.